Okay, welcome back everyone. So today we're just going to review section 4.1, which we already completed. I said it's a quick section. We spent one day. We're going to review it quickly here. And then we're going to get into 4.2 and practice that some today. So section 4.1 review, you should have this handout in front of you, and I'd like you to fill it in with me. So 4.1 is all about scale and scale factor. So there's two main key terms today, scale and scale factor. The formula for both is the same. So scale equals image dimensions divided by actual dimensions of an object in real life. So you might have a picture of a car and you might measure the length of it, and then you would divide by the actual length of the car in the same units, and you would get a scale. Scale factor, again, same formula. So scale factor is equal to image dimensions divided by actual dimensions. And the only big difference is scale factor. We actually divide the two numbers and we write it as a decimal or a whole number. It might be a whole number like 2. You could have a scale factor of 2. You might have made something twice as big. You might have a scale factor of 4. You might have made the object 4 times as big. But scale is always written as a ratio or a fraction. And scales are often written as a ratio of 1 to something. So you might have a scale of 1 to 100 on a map. Maybe 1 centimeter on the map is equal to 100 kilometers in real life. So that might be your scale. And you can also write a scale as a fraction. Okay. So what does this mean? What are some types of questions you could be asked? So I might give you a picture like this and these two rectangles here. We started with this one and then we did something to it. We multiplied by some scale factor and we made this rectangle. The first one is always considered to be the actual thing you started with, and the second one is always considered to be the image. So when you go to use your scale factor formula, we always do the second object, which is the image, divided by the actual. Okay, so what's the scale factor here? And there's actually answers down below, but you can ignore those for a second. What is the scale factor? So you're going to pick any length. So maybe you're going to pick the bottom length. On the image, it's 21. On the actual, it's 7. My scale factor would be 21 divided by 7, which would be a scale factor of 3. Okay, and that makes sense when you look at it. The picture got 3 times as big. And if I multiplied the bottom by 3, then the side, if it's a true enlargement, the side should have also gotten multiplied by 3. Okay, so my scale factor here would be A, 3. Okay, try the next slide yourself. We can even pause the video if we would like. What is the scale factor? Okay, now I know most people can look at this as you get good at this and you're gonna know the answer right quick. I'd still like you to show me your work. Scale factor equals image divided by actual. Okay, actual is the first one, image is always the second. Scale factor is equal to 16 divided by 8. That is a scale factor of 2. That means we multiplied the first shape by 2 to get the enlargement. Okay, last week we talked about if you have an enlargement, the scale factor greater than 1, okay, indicates an enlargement. So the answer we just got there was 2. Okay, that is correct because it is an enlargement we have. If you would have divided these in the opposite order, if you would have did 8 divided by 16, you'll get 0.5. Okay, that is incorrect because a scale factor of less than 1 would indicate that the picture got smaller, a reduction, and we didn't have a reduction here. We had an enlargement. So it's really important that you always do the second picture divided by the first to get the correct scale factor. Okay, so down here, which letter is 2? Okay, letter B. Okay, scale factor, still want scale factor equals image divided by actual. This is actual, this is image. Scale factor equals 4 divided by 12. 4/12 is the same as 1/3, which is 0.3 repeating. We have a scale factor of 0.3 or 1/3. We usually write scale factor as a decimal. I'm just noticing that this is a fraction. I would like them as decimals for scale factor. Okay, last one like this. What is the scale factor? Image divided by actual. 3 divided by 18. Okay, again, they don't have it as a decimal. I wish these were written as decimals. 1/6. 0.16 repeating. Okay, that is our scale factor. That means you would take any dimension on this first picture and you would multiply it by 0.16 repeating to get the dimension on the second figure. Okay. Another type of question you could be asked looks like this. So an actual Mustang GT car is 16 feet long. An image of it was drawn with a scale of 1 inch for every 2 feet. 1 inch on the image is equal to 2 feet in real life. How long is the image? So they're asking us to find image. They're asking us to find I. How long is the image? All right, so we need our formula. So scale equals image divided by actual. They're going to tell me 2 pieces of this, and we're going to solve for the third. I'm just going to hide this so I have some workspace here. Okay, so scale. Did they tell me the scale? They did. They told me 1 inch is 2 feet. 1 inch is 2 feet. Did they tell me the image? No, so I'm going to leave that as I or X, whatever you want to call it. And then did they tell me the actual length of the car? They did. It's 16 feet. Okay, so last week we learned that a little equation like this is called a proportion. This is a proportion where you have a fraction equal a fraction. And there's different ways to solve this. So we're going to solve for I, and I would ignore the units when I'm solving for I or X, whatever you want to put there. You can multiply both sides by 16 if you want to solve for I, or we said last week, when you have a proportion like this, you can actually cross multiply to solve them. 2 times I is 2I, and 1 times 16 is 16. And then we would just divide by 2. Okay, so I equals 8. How long is the image? So the image dimensions were inches. The actual car dimensions were in feet, but the image is in inches. Okay, and then a little sentence. So the image is 8 inches long. All right, if you flip your sheet over there's just a few more little points. Do you know what to put in that first blank? A scale factor greater than 1 indicates an enlargement took place. I made it 2 times as big, or 4 times as big, or 1.5 times as big. And a scale factor less than 1 indicates a reduction. Okay, the last little review examples I wanted to show you are more like what you might see on the exam this year. Find the scale factor that was used there. What scale factor was used? So we did a few of these last week, but some of you were absent, the band trip or various things. Scale factor is image divided by actual. This is always your image. This is always your actual. You have to pick a side, count the boxes on the graph paper. Maybe we'll pick this side. Okay, how many boxes do we have? Okay, 6. And on this side we have 2. 6 divided by 2 is 3. Scale factor used here was 3. Okay, we would say that this square is 3 times as big as this square. Okay, how about this guy? You can pause the video and try it yourself. The scale factor used image divided by actual. This is our image by actual. It's always the second divided by the first. Pick a side. Does yours look as wonky as mine? It does. Okay. So maybe we'll pick the bottom. That looks like 2.5 squares. 1, 2, 3, 4, 5 squares. So we're going to do 2.5 divided by 5. 2.5 divided by 5, of course, is a half. Okay, a scale factor of a half was used. And does that make sense? The scale factor is less than 1, so we have a reduction that took place there, okay? Okay, so that's a great review of, somewhat a great review of 4.1. just to kind of catch everyone up on last week. And you can pause this video or continue playing if you'd like to see examples from 4.2. So my 9Bs really need to see these examples. So 9Bs, you should have another sheet with some 4.2 examples. Okay, and this is what you're going to practice today. So 4.2 is all about giving you a diagram that is drawn to scale, we say. So every piece of the picture has been either enlarged or reduced by a certain amount, and it's the same amount for every piece on the picture. So for example, this picture here has a scale of 1 to 32, meaning 1 centimeter on the picture represents 32 centimeters on the actual car. Okay, so remember that scale is always image to actual. 1 centimeter on the image is equal to 32 centimeters on the actual car. So we're going to use these scales now to solve some questions. So you're going to jump to example 1 with me. This is out of your textbook. Okay, 4.2, example 1. All right, and we have a diagram of a skateboard. And the scale diagram of this skateboard uses a scale of 1 to 14. What is the actual length of the skateboard? That's what we're going to solve for. What is the actual length of the skateboard? So we need to use our formula. Scale equals image divided by actual measurement. Image measurement divided by actual measurement. And they're going to give me the scale. The scale is 1 over 14, so I'm going to put that in place of the scale. And then did they tell me the image measurement? They did, 5.5 centimeters. You can put centimeters if you want. I don't want to confuse people too much, so I'm going to leave it off. And then actual, what is the actual length of the skateboard? We don't know, so that is your variable. Okay, so we set up a proportion again here. This is a proportion. There's always a variable to solve for, and then we solve for it. Easiest way, again, with a proportion, cross multiplying. A lot of students really like that. You can do it that way. Or if you remember how you used to solve these equations, we would flip both sides and move the a to the top. Solve for a. Okay, you can do it that way if you want. Whatever way you want. But I'm going to cross multiply. 1 times a is 1a, and then 14 times 5.5. 14 times 5 is 70, and then half of 14 is 7, so it'll be 77. My units were centimeters up here, so my units are still centimeters. Okay, so our actual, we need a sentence. The actual skateboard is 77 centimeters long. Sorry, that is messy. Okay, pause the video now and try the show you know. It's the very same thing. Okay, so hopefully you've had a chance maybe to try this one yourself. We're given a scale for the diagram of the Chinook salmon. The scale is 1 to 9.2. That means 1 part on the diagram is equal to 9.2 parts in real life. Calculate the actual length of the salmon if the length of the diagram is 5 centimeters. You need your formula for scale, image divided by actual. I'm going to substitute my scale in for scale. My image has a measurement of 5 centimeters, so I put a 5 on top. And the actual salmon, I don't know, so I'm going to put A for actual. That is the setup. Then we need to solve for A, and we said this is a proportion. A fraction equal a little fraction. There's no plus or minus parts anywhere. So you can solve this easily with cross multiplying. So 1 times A is 1A. 5 times 9 is 45. 5 times 0.2 is 1. So we get 46. You can use a calculator there too. 46 centimeters. So the actual salmon is 46 centimeters long. Okay, these are the types of questions we need to be able to answer. Okay, the very last example I have for you. Example 2, determine the scale factor. Okay, I'm just thinking to myself, scale factor, I remember, is image divided by actual. It's the same formula as scale, but we always divide and get a decimal. That's how we find our scale factor. All right, an actual Canadian quarter, actual, has a diameter of 23.88 millimeters. Calculate the scale factor used to create the diagram of the quarter. Okay, so you need to measure, because we have the actual given to us, 23.88. I also need the image measurement, and then I can just divide those numbers, and that will give me my scale factor. So please take a ruler right now. Pause this and get one if you need it. You're going to measure the diameter straight across of that picture you have on your sheet. So your image on your sheet is like this size here. Okay, so you need to take your ruler. You're going to measure the approximate diameter. Actually, yours is a little bit bigger, kind of like that. So these large numbers here are centimeters, 1 centimeter, 2 centimeters. These little ticks are millimeters. So this quarter is 8 millimeters in diameter. So the image of your quarter is 8 millimeters. The actual is 23.88. So you're going to divide, and you would show this work. 8 divided by 23.88. That's the scale factor. 0.335. 0.335. Express the answer to the nearest tenth. So 0.3. Scale factor has no units. So the scale factor is 0.3. That's it. No units. Millimeters divided by millimeters, okay, is what gave us our scale factor, and those cancel. Okay, that's it. Happy practicing.